We'll implement a dual emergency stop using hardware and PLC logic by integrating an emergency stop or e-stop button into our existing configuration to establish a robust dual-layer hardware and software safety shutdown function. Required components include a PLC, a servo drive and motor, a 3-button control station, an S-on enable button, an e-stop button, and 3 interposing relays. All of these components are available from ATO, and you can find detailed product links in the video description below. This system keeps using PLC pulse output to control servo position. The PLC sends pulses and the drive runs the motor. Buttons control motion and safety logic ensures protection. Let's take a look at the actual system setup. First, the 3-button control station connects to the PLC input terminals. Next, look at the junction box. By running the e-stop in series here with the S-on enable button and also splitting a line back to a dedicated PLC digital input, we achieve our dual-layer emergency stop. S-on connects to CN3 pin 7 on the servo drive. Finally, wire the high-speed pulse output channels from the PLC to the pulse and direction input pins on the servo drive to handle the physical motor rotation. Now let's walk through the wiring schematic in detail. The diagram highlights 2 key sections: the 3-button station connected to PLC inputs, and the e-stop and S-on wiring configuration. The e-stop is wired in 2 ways: in series with S-on for hardware interruption, and to PLC input for software detection. Moving over, notice how the PLC input and output terminals are mapped to capture these safety and control signals. The CN3 table shows wire colors and pin mapping. Each wire connects to a specific function. Refer to drive connection section of your diagram. Connect mains power to L1, L2, and control power to L1C, L2C on the drive. For the motor, connect the U, V, W, and ground terminals. The encoder feedback cable is connected via CN4, allowing precise position feedback to the drive. Finally, the diagram includes the wiring of the 3 interposing relays. For a deep dive into the relay logic, check out part 2 of this series linked below. With the hardware wired, we need to configure the drive. First, initialize parameters. Press M set, go to FN005, select P init, and hold M set until Done appears. This resets the drive to factory defaults. Next, we must match the drive to our motor type. Go to PN0A0. Long press data and input the code for your motor. For our incremental encoder motor, that is N0007. Press M set to confirm. Finally, set the control mode. Go to PN000. Long press data and set the mode to position control. And press M set. Your drive is now ready for pulse control. Now let's move on to the PLC programming. Open your PLC software. Create a new project and set the device type to CP1E with the CPU type set to N40. In the ladder logic, the e-stop, SB1, is configured as a normally closed contact, meaning it remains on during normal operation. The control logic, press CW. The motor rotates clockwise at 20 kHz pulse frequency. Press CCW. The motor rotates counterclockwise. Press Stop. The pulse output stops, bringing the motor to a smooth halt. However, if you press the e-stop button, that NC contact instantly opens. This triggers an immediate stop to the pulse train and disables the CW-CCW start logic. The relays continue handling the limit protection logic. KA1 stops CW motion when the forward travel limit is reached. KA2 performs the same function for counterclockwise motion. KA3 is used for alarm reset, allowing the system to recover from fault conditions when necessary. Let's see it work. Press S on to activate the servo system. Press CW. The PLC outputs pulses, and the motor rotates clockwise. Press E-stop anytime. The motor stops immediately, not a slow deceleration, a hard stop. Simultaneously, the PLC cuts the pulse signal. This confirms the dual emergency stop function is working perfectly.